Okay, we are discussing that when applications, okay, the applications, it gets the data, it interacts with the users. Application layer protocol, it interacts with the users. So it gets the data from users, and now it changed the data from user format to system format, and now it gives application layer passes on the data to transport layer. So transport layer has to move the data from one application process to another application. So transport layer has to transfer the data from process to process. Now in the present internet, the transport layer, there are two types of protocols available, TCP and UDP. Now let's discuss how TCP forwards deliver the data and how UDP delivers the data. Okay, so let's discuss it. The TCP, it has these functionalities. It delivers the data from one application process to another application reliably. Reliable means that the packet is not lost, and the packet is delivered in that order in which the sender has transmitted. This is called reliability. Reliability means that the data is not lost. It delivers the data reliably. The data is not lost in the TCP, and the data is in order. The data is delivered to the user in that order in which it is transmitted by the sender. Okay. Second, flow control. The TCP ensures that the sender should send the data with that rate which can be processed by the receiver. For example, if the sender is sending data with 2 MB per second and the receiver can receive 1 MB per second, process 1 MB per second. So when the receiver receives 2 MB, so 1 MB will be processed by the receiver, 1 MB will be stored in the receiver buffer. And then a time will come when the receiver buffer will be full, and the more data arrives, then the receiver, the data will be lost. So in the flow control, there is a mechanism in the TCP that is called flow control, that the sender sends the data at that rate which can be processed by the receiver. If the receiver can process 1 MB data, so the sender will send 1 MB data. If the receiver can process 2 MB data, the sender will send 2 MB. So the sender will not overwhelm the receiver's capability. This is called flow control. Another is called congestion control. Congestion control means that the sender will send that amount of data that can be delivered by the core network. That is, the core network, the routers, they are not overloaded. Because if the router are overloaded, if the router buffer is full and the sender send more data, then what will happen? When the router buffer is full and the sender send more data, then that data will be discarded by the router. Why? Because if the router buffer is full and more data is arrived, that data will be discarded, will be lost. So the TCP provides the congestion control. The TCP doesn't provide timing, as we have discussed that the application may need these things, these requirements. For example, integrity. So the TCP provides integrity. The TCP doesn't provide timing. The TCP doesn't provide minimum throughput, and even this TCP doesn't provide security. So the TCP provides only data integrity, that the data will not be lost. Okay. So another feature of the TCP is that it doesn't provide timing, it doesn't provide minimum throughput, and doesn't provide security. It only provides reliability. And second thing, it can provide connection oriented. That is, before exchanging the data between two internet applications, the TCP, it established connection between sender and receiver. First the connection is established, then after establishing the connection, the TCP exchange the data reliably using flow control, that the sender will send that amount of data which can be processed by the receiver, and this sender in the TCP, the sender will send that amount of data that can be sent by the network, so that the network is not overloaded, because if the network is overloaded, the router buffer is full and more data arrives, then that data will be lost. So this is provided by TCP reliability. Okay, and second is the UDP protocol that is used at transport layer to transfer the data from source application to destination application. The TCP, it doesn't have reliability. Neither the TCP have flow control, congestion control, timing, minimum throughput, security, connection setup, nothing is there. The UDP, when it receives the data from application, it immediately sends that data to another application, and then it doesn't care whether the data is lost, whether the data is received, whether the data is not received, what is happening with the data. So it is not concerned. Okay, so and presently the requirements from the application can be these four things, but the internet, the TCP, it only provides data integrity, not timing, not throughput, not security at the transport layer. And the UDP, it doesn't provide anything of them. Okay, so if the UDP doesn't provide anything like reliability, there is no reliability, no flow control, etc., then why the UDP is used? Think about why it is used. It is used because some application they don't have such requirements. Some application, for example, okay, for example, some application like audio video, store audio video, like for example on YouTube you are watching video, so it can tolerate loss. For example, if you are watching a movie on YouTube and some part of scene is not displaying, but you can hear the voice, you can watch the characters, that's good. Okay, so for those applications they are using UDP. Okay, so these are the applications. For example, in current email, it is using TCP because the email requires that the data should not be lost. The telnet, it uses TCP, and the streaming media, it can use TCP or UDP. It depends. Okay, similarly the Skype can use TCP or UDP, both, but usually UDP is preferred. Okay, so if you want security, TCP cannot provide security, not the TCP, not UDP. So if you want to implement security, then there is another protocol which is called SSL. This protocol can be used to provide security, and we will discuss this protocol in chapter number 8. Okay, so till now what we have discussed the application layer protocols, general requirements. That okay, so general requirements of the application layer protocol are discussed. Okay, and what kind of transport layer services application can use, either TCP or UDP. So it depends on the application requirements that whether it should use TCP or UDP. Okay, so now we are going to discuss an application protocol that is used in practice. Okay, now we are going to discuss an application protocol that is HTTP. This is application layer protocol, and this application layer protocol is used for accessing websites, web servers, So let's explain it through example. First of all, a web page. What is a web page? A website. A web page, it consists of objects. Object can be HTML file, it can be a JPG file, image file, it can be a Java applet, it can be audio file, video file, PDF file, etc., etc., etc. But each web page, it consists of base HTML file, main HTML file, from where other objects can be referred, from where, which includes the reference to other objects. So basically a web page, it consists of objects. Object can be HTML file, JPG file, PDF file, Java applet, audio, video, etc. And each web page, it consists of base HTML file, main HTML file, where all other objects, they are referred. And on a web page, on a website, each object is addressable, is identified by using URL, which is called Universal Resource Locator. And the URL, it has two parts. One is called host name, the machine where the object is stored. This is called machine. The IP address, the host, the end system where the object is stored. And the path. Path is on that machine, on that end system, on that PC where the object is located. This is the path on that host, on that machine. Okay. So web page, it consists of objects. In a web page, there is a base HTML file where other objects are referred. And each object is identified by URL. And URL has two parts. One is host name, the machine, the IP address where the object is stored on that machine, and on that machine, on which folder, in which path, on which path the object is stored, so the path name. Okay. How the HTTP works? First of all, as we have discussed, that the application, there are two types of application architecture. There are two types of application architecture. One is called client server model and one is called P2P. So the applications architecture, they are of two types. One is called client server and one is called peer-to-peer. So let's discuss the HTTP use which type, client server or peer-to-peer. Okay, let's discuss it. So the HTTP, it use client server architecture. It use client server architecture. It is not peer-to-peer. So a client is running on a PC or mobile phone, etc., and server is running on a machine. Okay, so the HTTP is using client server model. The client like a browser, Internet Explorer, web server, Internet Explorer, Mozilla, etc., and server is running on another machine. So client and server, they both are using HTTP protocol to access the objects, the website, the web objects on the server. Okay, and how they should do it? The client sends HTTP request and the server responds with the HTTP response. So there are two types of messages, HTTP request and HTTP response. Similarly, the client can send HTTP request and the server respond with the HTTP response. So first, the HTTP use client server model. Okay, next, What are the options at transport layer? There are two types of options. One is called TCP or UDP. Okay, so the HTTP, it uses TCP, not UDP. So it means the HTTP requires reliable data transfer. Okay, so the HTTP uses TCP. In the TCP, before exchanging the data, the client initiates the TCP connection. So the client server, they establish connection. And when the server receives the connection request, the server accepts the connection. And when the connection is established between the client and server, then the HTTP data can be exchanged. Okay, so then the HTTP messages can be exchanged between client and server. And when the messages are exchanged, then the TCP connection can be closed. Okay, the HTTP is a stateless protocol. What does it mean? What does it mean? So I always explain it in the class through an analogy. For example, if I'm asking Josefa, what is your name? Josefa say Josefa. Then I ask again Josefa, what is your name? Then he says Josefa. Then I say Josefa, what is your name? So he will become irritated. What do you mean? Okay, but the HTTP is a stateless. Stateless means whenever you access, for example, a website, suppose nadir.com, nadir CV. So you send request nadir CV. The server will respond with the nadir CV. Then you access again request for nadir CV. The server will deliver you the nadir CV. When you again, anytime, even if you request for 1,000 times, each time the server will respond to you with that CV. The server will never irritate. The server will never get angry that I have provided you this CV now and why you are asking again and again. So this means stateless. Okay, so the server maintains no information about past client request. That means stateless. And by maintaining the state, it will become complicated. So that's why the server is kept simple. Server is kept simple. So if the past history is maintained, then the HTTP will become complex. So if server client crashes, then their views of state may be inconsistent. So it requires, so to avoid this complexity, therefore the HTTP is designed stateless protocol. Okay. Now there are two types of HTTP connections. One is called non-persistence. One is called persistence. As we have explained that before exchanging the HTTP messages, the HTTP, the application layer protocol, they establish TCP connection because they are using TCP at the transport layer to deliver the data from client to server and from server to client. So the transport layer, the HTTP uses TCP and the TCP have the connection establishment. So before exchanging the data, the TCP establishes connection between client and server. And once the connection is established, then the message is exchanged. So there are two options. One is that non-persistence. For each object, a TCP connection is established. For example, when the client accesses an object, nadir CV. So the TCP will first establish TCP connection between client and server, and then the nadir CV request, HTTP request will be sent to the server, and then from the server the response will be sent, the HTTP response. After this the connection will be closed. If the user again want to access the same object, for example nadir CV, or another object, nadir image, nadir photo, so again the TCP will establish connection. This is called non-persistence. It is used downloading multiple objects requires multiple connection. So if a user wants to access multiple objects at the same time, so they have to use multiple connection to establish multiple connection. Another is called persistent HTTP. In persistent HTTP, if a connection is established, then many objects can be sent and received on the same connection. So for each object, the user doesn't need to establish the connection again and again. This is called persistent HTTP. Multiple objects can be sent over a single TCP connection between client and server. Let's explain it through an example. Okay. Suppose a user, he or she wants to access this object. So an object is identified by URL. The URL has host name, IP address, and the path on that machine where the object is stored. Okay. Suppose the user wants to, okay, so first of all, when the client initiate connection, so the TCP will sends connection request, and connection request is sent to this machine. This is the machine IP address. So this machine name, IP address, it is taken from the URL, and the port number 80, because each application it is identified by two things, IP address and port number. So IP address a machine name can be get from the URL, and the port number it can be get because each web server is running on port number 80. So the port number 80 is understood by default. So the TCP sends connection request. After this, the TCP server responds with the connection accept. Okay. Now the connection is established in these two steps. After this, the HTTP message is sent that I need this object. So this is the HTTP request, and it will contain the URL that this on this machine this object is required. So the HTTP server, it will respond if that object is present with the server, so the server will send that object. If that object is not present, then the object will send that the object is not with me. Okay. So after this it is non-persistence. You can know non-persistence. So when one object is received, then the connection will be closed, because in non-persistence, on a single connection, TCP connection, single HTTP object can be retrieved. Okay. So after this, that TCP connection will be closed. So if you are accessing another object, so you have again to start from step number 1. This again you have to establish connection, and then you have to send the HTTP request for an object. Then you have to send the request for an HTTP object. Okay. So you have, if you want to access 10 JPG images, so you have to repeat for each object step number 1 to 5. Okay. So this is for the non-persistence HTTP. Okay. For persistence, so how much is the delay? How much is the delay? Let's explain it through an example. So what is RTT? RTT means round trip time. Round trip time means when you initiate connection. So when connection request is sent, it is received by the server, and then the server reply. So the time taken from here to here, this is called RTT. So one RTT is needed for TCP connection establishment, and one RTT is needed to send the object request. So HTTP request is sent, and then HTTP response is received. After this, the object will be transmitted. So the object cannot be transmitted in one packet. So if the file is, for example, 10 MB, so it depends on the file transmission time, on the bandwidth, the file size. So it will take some transmission time. So actually, if you want to retrieve one object, so you need one RTT for TCP connection establishment and one RTT for HTTP request and response, and then you need file transmission time. So this is the total time that is needed for non-persistent HTTP. 2 RTT plus file transmission time for one object. If you want to access 10 objects, so 10 multiplied by this time. Okay. Now it means that now study persistence HTTP. Persistence HTTP, non-persistent HTTP, it requires 2 RTT per objects. Why? 1 RTT for TCP connection and 1 RTT for HTTP request and response. In persistence HTTP, server leaves connection open after sending response. When the TCP connection is established and the HTTP request and response is sent, then the connection is not closed. The connection remains open, and subsequent HTTP message there can be sent on the same open connection. Okay, so the client can send request as soon as it encounters a reference objects. So it needs how much time? 1 RTT for all the reference objects. Okay, for all the reference objects. Okay, so let me explain it. So it means that let's suppose, so this connection is established. After this, 1 RTT is needed for one object. If you want to access another object in the persistent HTTP, so again you have to send the HTTP request and response. So only do you need 1 RTT for the HTTP message. You don't need to re-establish the connection because the connection is already established. Okay, so this is about persistent HTTP. Now we have discussed that application layer protocols, it defines what a protocol defines. Okay, so a protocol defines that what kind of messages can be exchanged. So in HTTP, what kind of messages can be exchanged? In the HTTP, the message that can be exchanged, HTTP request and HTTP response. And second thing is that the protocol defines syntax and semantics. So let's discuss it. What is the syntax and semantic of HTTP protocol? Okay. The HTTP request message, this is the format. And HTTP request message, this is called request line. The request line, this get is keyword. This means object request for object. And this is the path. There is space and then is the path. And the path can be taken from the URL. And this space, this is the syntax, that there should be HTTP version. Then a new line. Carriage return line feed means new line, start of the new line. These are called header lines. These header line can be in any header, no problem. But this request line should be first one in the HTTP request message. The HTTP request message is in the ASCII format, human readable, so you can read it and you can understand from this header line what does it mean. Okay, this header line can be in any header. Host, it is a keyword and it defines the machine where the object is requested is stored, and this host can be taken from the URL. Okay, and then a new line, user agent, that what is the agent, the client, for example it is using Firefox 3.6 or Internet Explorer 1.5 version, etc. Accept, that what kind of file it can accept, text and HTML. Accept language, it can accept English and US version or UK version. Okay, international version. Okay, encoding, accept. So all these things, they are available in the HTTP RFC. They are available in the HTTP RFC. Keep alive, what does it mean? It means persistence HTTP. Keep alive means persistence HTTP. Okay, so the connection is keep alive. It means that it requires persistence HTTP. That when the connection is established and the object is retrieved, then the connection should not be closed. Okay, after the header lines. So these header lines defines that how the object should be requested. Okay, so this actually defines that how the object is requested. Okay, and when all these information are finished, then there is two carriage return line feed. After this there can be data. For example, when you fill up the form, so you request that I need this information, but you provide some information that what do you need. So these information or form input can be attached here after these two carriage return line feed. Okay, this is the general format of the HTTP request. Method, we will discuss. Method can be like, for example, get. Get means I need this object, then space, then URL path, then space, then HTTP version, then next line, then each header line, and each header line value, and then on each line there should be one header line, and these header line can be in any order. So it defines how the HTTP object should be request, should be forward, should be processed. And after all these things are defined, then if you want to send input data in the form to the server, so this can be attached here in entity body. Okay, we have discussed just one method, and that method was get method. So there are also some other methods. So let's discuss these other methods. The method post. The post method is often used. Why it is used? Sometimes if you use get method, so when you input the data, that data appear in the search in the URL header like this way. So if someone is sitting with you, so that person can see that what did you input, so it can say your data. So if you use post method, then in the post method these input data will not appear in your URL. So the difference between get and post method is simple. In the get method, if you input the data in the request of HTTP, so that input will appear in your URL. But in the post method, that input data will not appear in the URL, that will not appear. Okay, so you can say that it is somehow secure. Okay, the HTTP 1.0, it has three methods: get, post, and head. And you can see it, you can study in their RFC. The head method, it is used for testing purpose. Its meaning is same like get, but when for example, if you send a request with the head, HTTP request with the head, and you see another CV, so the HTTP server will respond, but it will not send the CV. Why? Because if you are doing testing and you request an object, for example, you request an object, a movie Tare Zameen Pe, and that movie is 30 GB, then it will take transmission time, for example, 3 hours. So when you send the request and then you receive the response, and it takes 3 hours because the movie will be downloaded. So and then you say, okay, there is something missing, so you then again implement that, and then again you send the request. Okay, so it takes a lot of time. If you are doing testing, then you should use head. With the head method, when your request is sent to the web server will respond, but web server will not send you the object. It will only send you OK response. Okay. And in HTTP 1.1, there are other two methods. One is called put and one is called delete. The put method is used to upload a file on web server, and the delete method is used to delete a file from the server. Okay. Similarly, when the HTTP response is received, okay, so we will discuss the HTTP response in the next class. Okay, so I think for now it is okay, it is finished. Okay, so the HTTP response, it will be discussed in the next class. Okay.